So section 4.4 is going to work on some formulas that help us find the area of a triangle. There's going to be two. One of them I don't really think has a name. The other one's called Heron's formula. It's been known since ancient Greek times. But let's figure it out in general terms first. How do you find the area of a triangle? What's the formula? Thank you. One half base times the height. So there's your base, there's your height. That's perpendicular to the base. Now let's see if we can replace the height with something. So is there some trigonometric formula that I can use that involves the height, maybe a known angle, and another known side? What involves these three pieces of information? All right, sine of gamma equals what over what? H over A. If I multiply both sides of this equation by A, I get A times the sine of gamma equals H. All right, that's cute. Where is this all going? Well, let's plug it in to this formula over here and see what I get when I rearrange this. I get A equals 1/2 B times A times sine of gamma, or if I rearrange it, 1/2 AB sine of gamma. So it's 1/2 of the product of these two sides times the sine of the angle between them. That's your formula. And there's different versions of it depending on what angle you're dealing with. So this is just the first version. What if I was looking at things from the point of view of alpha? Well, it'd be 1/2 B times C times the sine of alpha. So that's the second version. And kind of like what I did with the law of cosines, I want you to come up with a third version. So try and get the general pattern here and write down what that third version would be. So I'll give you a second to look at that. Don't shut it out. Let people try and figure that out for themselves. Fahad, what would that be? What would be the last version here? Good. 1/2 A times C sine of beta. Perfect. So two sides that don't include the angle opposite or the side opposite of this angle. All right, well done. Let's see if we can apply that. And we'll start with, I think, problem 14. Let me just make sure I'm at the right page. Yeah, problem 14. A, B, and C, alpha, beta, and gamma. Oops. There we go. A is 2, B is 1, and beta is 10 degrees. C is 1? Oh, sorry, C is 1. Yeah, that's better. C is 1. Yeah, that's going to make this a little bit nicer. C is 1. So this is nicely set up for using the law of, whatever you want to call this, to find the area. Which one of these, 1, 2, or 3, should I use? Yeah, the third one. So 1/2 A times C, 2 times 1, times a sine of 10 degrees. Those cancel, so it's just going to work out to the sine of 10 degrees, which is going to be a pretty small number. About 0.1736. Okay, and that's it. Now there's another formula that we can use that helps us calculate the area of a triangle. In this case, it would depend on just the sides. So it doesn't depend on any of these angles at all. Like I said, this is a really, really old formula. Heron was an ancient Greek mathematician. So Heron's formula. The first thing you're going to have to calculate in using Heron's formula is something called the semi-perimeter, the distance of the semi-perimeter. So what's that? Well, if you have a triangle with sides of A, B, and C, the perimeter would be A plus B plus C. Half of that is your semi-perimeter. So S equals 1/2 A plus B plus C. So what's Heron's formula then? The area is going to be the square root of S times S minus A times S minus B times S minus C. So it's completely devoid of having any sines or cosines in it. It just depends on S. Let's take advantage of something that we know back from problem number 18 in section 4.3. We actually dealt with this triangle before, and I think the length of side B that we solved there was like 1.03. Someone want to look back on that? Check that. 1.03. Yes, number 18. So with that, then I can calculate S, the length of the semi-perimeter, and then I can run through Heron's formula. So let's do that. S is going to be 1/2 2 plus 1.03 plus 1. So half of 4.03, or better yet, 2.015. So that's S. We don't even need to actually calculate it separately ourselves like that. Here's what I would suggest you do. Let's take 0.5 times 2 plus 1.03 plus 1 and store that in X. So the store key is down here on the lower left hand side. X is right next to the alpha button. Store that in X like that. Let me get the 2.015. Great. Next, what I want to do is run through Heron's formula. So it's all this. That's made easier by the fact that we already calculated the semi-perimeter. So hit the second button, then the square root key, and then I want S. Well, I didn't store this in S, I stored it in X. So I'm going to do X, and the left parenthesis, X minus A. Well, what was A? A was 2. So it's going to be X minus 2 times parentheses X minus 1.03 times parentheses X minus 1. So we're letting our calculator do all the work here. Wow. And we get the same thing that we got just a minute ago when we used the formula involving the sines. So it depends on what you're given as to which formula you want to use. Do you want to use the one with sines? Great. Do you want to use the one that just depends on the sides? It depends on what you're given. So let's try one more like that. Problem number 24. Are you okay with this one? Problem 24 just gives us the length of the sides of a bunch of these things. Yeah, you're always taking the positive root because we're going to be talking about an area. So it would definitely be the positive root there. Thanks. That's a good question. Problem 24. So A equals 4, B equals 3, C equals 6. So again, let's see if we can't set up Heron's formula. I need to first calculate S as the semi-perimeter. S is going to be 1/2 of 4 plus 3 plus 6. I'd suggest that you store that value and then finish off Heron's formula using the same technique we did with the previous one. Store that, and then just type it all in. Excellent question. Yes. Squared. Yeah. What are you getting for this one? 5.33. Perfect. So you should get 5.33 something. Okay, good. So the area is 5.33. In case you didn't hear Derek, his question was, would the area be in units squared? Yes, it would be. So if this was feet, it'd be in feet squared. If it's in yards, yards squared, meters, meters squared, etc. But area is always in square units. Now, this one in particular, again, this is a problem we've already visited. So I think this was problem number 30 from section 4.3. Let's take advantage of the fact that we know that alpha, beta, and gamma from that section were 36.33, 26.38, and 117.28. Let's see if we can't use our other formula to confirm this area result. So we had 3 different versions of that other formula. These 3 right here, just pick one of them. I mean, you've got the information to do all 3, but just pick one of them. Someone want to choose one for me, or should we just... Which one? First one? So go in the first one. A equals 1/2 AB sine of gamma. Let's see if we get the same thing. Filling this in, it's going to be 1/2 4 times 3 times a sine of 117.28. Let's see how that looks. So that's 12 divided by 2 is 6. So I'm just going to type in 6 sine of 117.28. 6 sine of 117.28. And looking pretty close. 5.33 again. So a couple different ways to get those areas. Nice. All right. Question for you. Well, first of all, are we okay with Heron's formula and these area formulas for triangles? Okay. Let me give you some homework. So homework, section 4.4. Try 5 through 21 and 33. I know that sounds like a lot. I know, but all right, I'll give you a week to work on it, okay? 5 through 21 and 33. So that's really like 9 problems, I think. Nothing that big. What part of today's lecture are you still the most foggy on? Like, you know, I could use one more like this. What would it be? If you were to do one more problem, what would it be? more problem to practice. What's that? This one? Which part of it? The Heron's formula part or this one? I'll tell you what. Here's an easy way to get some more practice with this. Let's set this up for a different angle. Suppose you wanted to find the area, but you're going to use beta as opposed to gamma. You already, all right. We did gamma. If we wanted to use beta, so then what formula would I use? I'd use 1/2 A times C times the sine of beta, right? So it'd be 1/2 4 times 6 times the sine of 26.38. It should still give me the same thing again. Let's verify that it does. So that's going to be 12 times the sine of 26.38. 12 sine of 26.38. And again, 5.33. So it's kind of a cool formula. It's pretty easy to apply. 5.33 units squared. All right, let me ask it again. I'll let you go early. Just tell me what problem that you're like, you know, if I had more time to practice, if we weren't leaving right now, which we are, then I'd... Which one? The two cases with the sine? Okay. 2 cases with the sine. All right. Good enough. We'll see if we can't do a practice problem or 2 extra on the 2 cases of the sine. In the meantime, have a great weekend. See ya.